In this video lecture, let us practice creation of a rocket engine using the revolve command. So I have this geometry with me on the right hand side of the screen. Let us try to utilize these options and let us try to create the particular rocket engine. So this is a Russian rocket engine, and the name of the rocket engine is RD106. It is a very old rocket engine, so that is the reason I was able to extract the dimensions from some internet resource. I will be attaching this particular geometry in the resources so that you can practice on your own. So whenever you are finding any geometry which is having diameters present in it, for example, you have a diameter dimension present over here, and you have a diametric dimension present in the throat region, and you have the diameter present in the exit region. So whenever you are finding this kind of dimensions, one thing should come into your mind immediately. That is to create the particular geometry using the revolve command. So right now let me just zoom out. And as I already mentioned many a times that it is very good idea or a good technique to analyze the geometry given to us. So let me zoom in. This particular section is the combustion chamber where the hot gases are getting combusted and entering into this region. And from this particular region you have the throat where the gases get compressed over here and they exhaust through the nozzle region into the atmosphere at high speeds. Coming to the diameters or the dimensions, we have a dimension of 600 units over here, and this is the diameter of the circular cross section of the combustion chamber, and the distance from this particular edge to this point is 802 units. Then we have a compressing region or a converging region whose angle is given to us, that is equal to 50 units. And we have the throat diameter, that is 278.8 units. After which we have the nozzle whose radius is something around 7900, and we have the diameter of the exit of the nozzle, which is equal to 1260 units. So I am considering millimeters and I will be designing this geometry. When we are creating the sketch, the problem is very simple the geometry is very simple to create. We only have to create the sketch and then we have to revolve it. So first we have to understand what section of the sketch are we creating and what is the axis that we are going to consider for revolution. So the default geometry alignment is in this way. You can see it is from left to the right. It is not from the top to the bottom. So it is from the left to the right. Clear? And the central axis of the rocket is, the central axis of the rocket engine is a horizontal line. So what we can do is, for the axis of revolution, we can consider the x-axis, that is the horizontal axis. And for the sketch, we only have to create half the sketch or half the cross section of the total geometry given to us. So in this case, we will try to create the upper half. So we will be having the sketch ready with us, and we will also have the axis of revolution, which is going to be the x-axis. So when we are ready with both the things, we only have to create the revolve option. Use the revolve option and create the revolve geometry. So what is the larger or maximum work present over here? The maximum work is only with respect to the sketching part. So let me begin creating this particular sketch, and so first I will be clicking on the revolve command. So the orientation of the particular geometry can be worked on the front view. Aligning the view to the normal, And as I have mentioned, we have to create the upper half. So right now, let me choose the line command. And let me start from the center point or the origin. So the diameter of this upper half, we have the diameter present to us, that is equal to 600 units. As we are sketching the upper half, we have to divide it into 2, and that will be equal to 300. So I can directly type 600 divided by 2. So this is the upper dimensions. There is one more way for working on this. I'm talking with respect to the dimensions. For that, let me press Ctrl Z. I have the sketch what I have created, that is a vertical line. Now I can create a center line. And for getting a dimensions which are quite similar to the diametric form, I can click on dimension. And before this, I have created a center line. So click on dimension, click on the edge, select the center line, come back to the edge and press middle click. So you will be having the dimension with respect to the diameter. And in this case, you can directly type 600. So this is a dimension which is with respect to the diametric form. Now let me move 800 units ahead. So this is a simple exercise which is basically in the form of sketching what we have already completed in the previous sections. So we are just doing the same thing. So I have created this particular distance of 802 units. Now let me create a point over here by using the point option randomly at some location. So this will be the throat. The point what I have just created is the point of the throat, and which is having its own diameter, that is 278.8. Now the distance of the throat to the inlet section is 1258. So I can change the distance over here, and automatically I'm getting some dimensions over here, that is from the point to the inlet section. So I will be changing it to 1258. Now I can simply connect it with a line. After connecting with the line, I have to give a radius of 300 units. So for this, I can use the fillet option. I can use both the edges and change the units to 300. So right now there is a difference. The dimension 1258 is with respect to the center point, but I have also one more dimension to maintain, that is equal to 802 units. So the moment I have created the fillet option, I believe there is a change in it. Let me just verify. Yeah, this has to be 802. So this dimension will hold the fillet in its position. Now let us move forward and let us create the exit of the nozzle randomly at any location. And this has to be again in the form of diametric representation. And the diameter over here is equal to 1260. Let me zoom out. Now what is the distance between both the ends? That is equal to 3118. So I can click on dimensions and change it to 3118. and zoom out. Now let me just try to hide it. Yeah, so as of now we have created this section. We have to connect it to the outer edge. So let me turn on the dimensions. Directly click it with a line. But over here, if you're noticing, we have a radius of 7900. So let me delete the line and go to arc. In arc, we have the 3-point arc. Select that one, select both the edges, place it at random location. Now we have the dimensions over here, which is around 8800, and let me change it to 7900. So it has changed. We also have a radius over here that is equal to 278. We have to use the fillet for this. Click on both the edges. We have the fillet command. Adjust the radius to 278. Verify whether the main dimensions are at the same position or is there any change in the dimensions. So you can observe over here that the point what I have created, which was supposed to be the reference of the throat, is at this location, which is equal to 1258, but the rocket throat has moved forward. So we can just change the dimensions again. This generally happens when we are employing the fillet command to change the dimensions. So right now it is at a position of 1294 and I need to change it to 1258. So most of the dimensions have been created. Now you can simply create a horizontal line to make it a closed loop. So we have the sketch ready with us and we have the axis of revolution, which will be the horizontal axis. So click on OK, and the moment you have clicked OK, you can see the rocket engine ready over here. You again have to press OK. And you have the rocket geometry ready right now. So this is a procedure of working with Revolve command. And this is a very simple geometry if you are working with any research project and all, and if you are finding any geometric dimensions which are given to you in the form of diameter, then you can utilize the Revolve command and you can work with it. So what is the application of this particular geometry? Where have I used it? So I will be discussing that particular details in the next video.